Hi everyone, how are you? Welcome back to Morhari Maths online classes. Today we discuss about determinants JEE Mains previous year's questions. Okay, in the statement A 3 by 3 matrix given, adjoint of A value as well as B matrix is given. What is B given here? Adjoint of A. The lambda value here, lambda value delta of A, mu value delta of transpose of B inverse. Then find out ordered pairs modulus of lambda comma mu. So from statement, adjoint of A is 2 minus 1 plus 1 minus 1 0 2 1 minus 2 minus 1 given. Okay, first find out delta of A value. How to find delta of A? Now taking delta on both sides. Now taking delta on both sides. What we get here? Delta of adjoint of A is equal to delta of 2 minus 1 1 minus 1 0 2 1 minus 2 minus 1. It will becomes here plus minus plus. After simplification we get 9. Delta of adjoint A, we have one formula delta A power n minus 1. But n value here, how much value? N value 3 by 3 square matrix is given, n is equal to 3. Is equal to 9. Delta A power n minus 1. 3 minus 1, it will becomes delta A whole square is equal to 9. Delta A we get plus or minus 3. Delta A value plus or minus 3. But delta A value from statement, what is given? Mu, lambda. Lambda is equal to delta of A is equal to plus or minus 3. But required is here modulus of lambda is required. Modulus of lambda is equal to modulus of plus or minus 3. What we get here? 3 only. Then after find out mu value. But mu, what is the mu given? Mu is equal to transpose of B inverse. Delta of transpose of B inverse. Okay, we have one formula delta of P is equal delta of transpose of P. So delta of transpose of B inverse is nothing but delta of B inverse. Delta of B inverse is det B whole inverse. Det B whole inverse is nothing but 1 by det B. First find out det B value. From B value, from statement B matrix, what is given? Adjoint of A. Now taking delta on both sides, det B is equal to delta of adjoint of A. What we get here? Delta of adjoint of A is nothing but delta A power n minus 1 whole square. We have one formula. But delta A value here, what we have got it plus or minus 3. Plus or minus 3 times of plus or minus 3 power n minus 1 whole square. But n value here, how much value? 3. 3 minus 1 whole square value 4. What we get here? 81. 3 to the power 4. Okay, therefore mu is equal to 1 by det B value we have got it 81, 1 by 81. So what is required? Final required is modulus of lambda comma mu. This is nothing but modulus of lambda we have got 3 comma 1 by 81. Okay, now explain a statement. In the statement matrix A as well as unit matrix given, then find out 10 A inverse. So all options combinations are in terms of A or I there. Okay, now this kind of problems by using characteristic equation formula. Characteristic equation of the matrix A. Okay, we have one formula modulus delta of A minus lambda I. is equal to 0. Det of A minus lambda I is equal to 0. Det of A matrix here, right, 2294 minus lambda times of unit matrix, right, 1001 is equal to 0. Okay, now do subtraction these two matrices, 2 minus lambda. Next 2 minus 0. 2 minus 0 is 2. 9 minus 0 is 9. 4 minus lambda. After data simplification, what we get here? 2 minus lambda into AD minus BC formula, right? 2 minus lambda into 4 minus lambda is equal to minus 18 is equal to 0. Okay, we get here lambda square minus 6 lambda minus 10 is equal to 0. But each square matrix satisfies its own characteristic equation. Okay, here lambda placed in right a square minus 6a minus 10. 10 is nothing but 10 into I. Okay, now what is required here? A inverse is required. Now pre-multiply A inverse on both sides. What we get here? A inverse A square minus 6 into A inverse into A minus 10 times of A inverse into I is equal to O. So A inverse into A square here, 1A get cancelled, A minus 6 into A inverse into A is nothing but unit matrix I minus 10 times of A inverse into unit matrix is A inverse. Okay, minus 10 A inverse sending right side. What we get here? 10 A inverse is equal to A minus 6A. A minus 6I. A minus 6I. Which option is correct? Second option is correct. Okay, now explain next statement. In the statement, A square minus A plus I is equal to O. Then the inverse of the matrix A. How to find? In statement, A square minus A plus I is equal to O given. So what is our required? A inverse is required. So now we should multiply A inverse on both sides. So pre-multiply or post-multiply A inverse on both sides. So A inverse into A square minus A inverse into A plus A inverse into I is equal to A inverse into O. So A inverse into A square. So A inverse into A, right? A inverse into A, how much value? I. A inverse into A is equal to I. IA. A inverse into A, again write here I. A inverse into I is equal to A inverse. Any matrix into unit matrix is equal to same matrix. So here write A inverse is equal to null matrix into anything, null matrix. So what is here I into A? How much value I into A? I into A is nothing but A minus I is equal I plus A inverse is equal to O. So here required is A inverse. A inverse is equal to here minus I plus A. Sending right side, what we get? I minus A. This is the answer. Okay, now explain next question. Here AB two invertible matrices of order 3 by 3. Two conditions are given. Det of AB A transpose is equal to 8. Det of AB inverse is equal to 8. Then find out det of B A inverse B transpose. So what is the statement here? Det of AB A transpose is equal to 8. So this we have one formula. Det of ABC is equal to det A into det B into det C. So det PQ is equal to det P into det Q. Okay, now we should apply first formula det of ABC. Det of A into det of B into det of C. We get here det of A into that of B into that of transpose of A is equal to 8. But here, that of transpose of A, that of A both are equal. Okay, I will give one example. Let us take that of A is equal that of 1, 2, 3, 4. How much this that value? 4 minus 6 minus 2. That of transpose of A, how much value? Its transpose is 1, 3, 2, 4. This that also say minus 2. So that of A, that of transpose of A both are equal. So that implies that of A into that of B into transpose of A value is nothing but that of A. Okay, here let us take this is equation 1. The second equation, what is given here? That of AB inverse is equal to 8. Is nothing but that of A into that B inverse is equal to 8. That of A into that B inverse is nothing but that B whole inverse. Okay, we have one formula. That of P inverse is equal to that P whole inverse. Okay, that of A into that B inverse. That B is one of the constant. Constant power minus 1 is nothing but 1 by constant. Is equal to 8. This is second equation. Okay, now multiplying equation 1 and equation 2, main our target that A, that B values. Okay, now multiplying equation 1 and equation 2, what we get here? That A into that B into that A into here that of A by that of B is equal to 8 into 8. Here that B get cancelled. What we get here? That A into that A into that A whole cube is equal to 8 into 8, 64 can be written 4 cube. What we get if bases equal, if powers are equal, bases also equal, that A is equal, we get 4. That A value, how much value we have got it? 4. So that A value substitute in second equation or first equation, we get B value. We get that B value. From second equation, that of A by that of B is equal to 8. Here that A value, how much value? 4 by that B unknown value is equal to 8. So that B we get 4 by 8. 4 by 8 is nothing but 1 by 8. But what is required here? Required is, this is required. That of B A inverse B transpose. That of B A inverse transpose of B is nothing but that B into that A inverse into that transpose of B. That B into that of A inverse is nothing but that A whole inverse. That B transpose. That B transpose of that of transpose of B, that of B both are equal. Here that B value already we have got it 1 by 2. So that B into that B by that of A. So that B value 1 by 2 into 1 by 2 by that of A value 4. What we get here? 2 2 is 4, 4 4 is 16. 1 by 16 answer. Okay, now explain next statement. In the statement, one matrix A given as well as B is equal to adjoint of A, C is equal to 3A. 3 times of matrix A given. Then find out that of adjoint of B by that C. What is required here? Required is that of adjoint of B by that C is equal to that of adjoint of, here B matrix placed right, adjoint of A by that C. That C value from statement given, C value, how much value? 3A, that of 3A. Okay, we have one formula. That of adjoint of adjoint A is equal to, what is the formula? Det A power n minus 1 whole square. If three adjoints are there, what is the formula? Det A power n minus 1 whole cube. Okay, right, first formula det A power n minus 1 whole square. So we have one more denominator, det of 3a. Det of Ka, one more formula is there. Det of Ka is equal to k to the power n into det A. Here k to the power n into det A. But here k value, how much value here? K value 3, n value 3. 3 to the power 3. Here k value 3, n is order of A. This is also 3. So det A power n value, how much value here? N value 3 minus 1 whole square. It will become 4 by 27 into det A. One det A value get cancelled here. Det A to the power 4 here there. Det A whole cube by 27. First, from statement matrix A given, A is equal to 1, 1, 2, 1, 3, 4, 1, minus 1, 3. Now find out det of A. The det of A is equal to det symbol. This is the plus minus plus. So after det simplification, we get det value, det of A value 6. Here 6 cube. 6 cube by 27. 6 cube is nothing but 216 by 27. 27 1j, 27 8j get cancelled. What is the answer? 8. Okay, now explain next question. In the statement, matrix P given is the adjoint of 3 by 3 matrix. Adjoint of 3 by 3 matrix A. As well as det of A value 4. Then find out alpha value. So here P is the adjoint of 3 by 3 matrix. P is equal to adjoint of A. Now taking det on both sides. Why? Because in the statement det of A value given 4. So det P is equal to det of adjoint of A. So if from statement P matrix is given, det P how much value? 1 alpha 3, 1 3 3, 2 4 4. 3 plus minus plus. So plus 1 into how much? Here 1 present in first row, first column. After deleting first row, first column, what we this det value is 0. 12 minus 12. Minus alpha times of, here alpha present in first row, second column. After deleting first row, second column, what we get? 1 into 4, 4 minus 6 minus 2. Plus 3 into here this value, 4 minus 6, 2. So here what we get here? 4 minus 6 minus 2. Sorry. Here what we get here? 2 alpha minus 6. 2 alpha minus 6. So det P value 2 alpha minus 6 is equal to det of adjoint of A. We have one formula, det A power n minus 1. Where n is order of square matrix. Here order of square matrix, how much value? 3. So n place and write 3. N is equal to 3. Det A value from statement 4 given. So 2 alpha minus 6 is equal to 2 alpha minus 6 is equal to det A value here 4, 4 to the power 3 minus 1. 2 alpha is equal to here 4 square 16 plus 6. 2 alpha is equal to 22. Alpha we get 11. What is answer? 11 answer. Okay, now explain next statement. In the statement, A is invertible matrix as well as det of adjoint of 24A is equal to det of adjoint of 3 adjoint of 2A. Then find out det A whole square. How to find this value? Okay, we have one formula. Adjoint of det of adjoint of A is equal to det A power n minus 1, where n is order of the given matrix. Here order how much value? 3. 3 by 3 square matrix. So n is equal to 3. Now this is applying this formula. Here A place in 24A is there. So det of 24A power n minus 1, 3 minus 1 is equal to. Okay, now we should applying same formula here. Adjoint of, let us take this total matrix is A. 3 adjoint of 2A place in right A. Det of adjoint of A. Now applying same formula, what we get here? Det A. A place in right 3 adjoint of 2A power n minus 1. 3 minus 1. Okay, now here now taking square root on both sides, what we get here? Det of 24A is equal to here square get cancelled. Det of 3 adjoint of 2A. Okay, we have one more formula. Det of Ka is equal to K to the power n into det A. Here where K value how much value? 24. Okay, now we should applying same formula. K to the power n, 24 to the power n value how much value? Here 3. Det of A is equal to, here K value how much value? 3. A matrix place in, here adjoint of 2A there. A place in, we should write adjoint of 2A. What we get here? 3 to the power n. N is nothing but 3 here. 3 to the power 3 into 3 to the power 3 into det of adjoint of 2A. Okay, here 24 can be written as 2 cube into right prime factors, 2 cube into 3. 8 3 is 24 whole cube into det of A is equal to 3 cube into det of adjoint of 2A. Now we should apply the same formula. Det of adjoint of A. Here A place in what is there? 2A there. So det 2A power n minus 1. N value here how much value? 3. 3 minus 1 is 2. Okay, here 2 cube power 3, 2 power 9 into 3 cube into det of A is equal to 3 cube into, again we should apply this formula, det of Ka. K to the power n into det A. Here K value how much value? 2. 2 to the power n value how much value here there? 3. 2 power 3 into det A whole square. Here both sides 3 cube get cancelled. 2 to the power 9 into det of A is equal, this value how much value? 2 to the power 3 whole square, 2 to the power 6 into det A whole square. So both sides one det A cancel as well as 2 power 6 also cancel, 2 power 3. So we get det of A is equal to 2 cube. What is required? Det of A square is required. Required is det of A square. Now 2 cube power 2. How much was the answer is 2 to the power 6. So 2 to the power 6 is correct answer. Okay, now explain next statement. In the statement, A be a matrix of order 3 by 3 and det of A value 2 given. Then find out det of A into adjoint of 5 adjoint A cube. So what is required here? Det A into adjoint of 5 adjoint A cube. Okay, we have one formula, adjoint of Ka is equal to K to the power n minus 1 into adjoint of A. Okay, right here K value 5. Here A place in adjoint of A cube there. Now applying this formula, what we get? K to the power n minus 1. 5 to the power n minus 1. N value, how much value here? N is equal to 3. 5 to the power 3 minus 1. Here adjoint of A place in right, here adjoint of A cube. Adjoint A cube. Have you understood? Here, now, what is the, now we should apply this formula, adjoint of Ka. What is the formula? K to the power n minus 1 into adjoint of A. But here K value, let us take 5. A place in right, here what is their adjoint of A cube? According to this formula, K to the power n minus 1, 5 to the power 3 minus 1 into adjoint of A cube. Okay, that A into this value, how much value? 25 into adjoint of A cube. Okay, we have, this is, that A is constant. 25 is also constant. This is total is constant value. Okay, now we should apply this form, that of Ka is equal to K to the power n into that of A. Here K value, how much we are there? That of A into 25. But that A value from statement, this value given 2. Okay, right. 2 into 25, 50 into this value 2 given. 50 into adjoint of A cube. Okay, here K value 50. This is adjoint of A cube. Let us take matrix A. According to formula, right? K to the power n. 50 to the power n value, how much value here? 3. K to the power n into that of A. That of adjoint of A cube. Okay, we have one formula, same formula. That of adjoint of A. Okay, we have formula that A power n minus 1 whole square. So 2 adjoints are there, right? That A power n minus 1 whole square. If 3 adjoints are there, that A power n minus 1 whole cube. If r times adjoints are there, what is the formula? That A power n minus 1 power r. Okay, we get 50 whole cube. Now, according to this formula, right, that A power, that A. Here A plus what is there? A cube is there. That A cube power n minus 1 whole square. N value, how much value? 3. 3 minus 1 whole square. So 50 whole cube. Here, here 4, 4 3 is 12. That A power 12 here. Okay, here 50 whole cube into that A value from statement 2 given 2 to the power 12. 2 to the power 12. So 50 place in right, 25 into 2. 25 whole cube. 2 whole cube. 2 to the power 12. So how much 12 this is? 25 into 25 into, so in answer 10 power 6 combination is given. 25 into 2 into 2. 25 2 is 50, 52 is 100. Power 3 into here total 2 power 15 here there. Here 2 power 6 into here 2 power 9, right? Here 25 into 2 into 2, 10, 100 whole cube into 2 power 9, 2 to the power 9. 2 to the power 9 value 512. Here 100 place in that 10 square. 10 square whole cube is 10 power 6. Which option is correct? First option is correct. 512 into 10 power 6. Okay, now I am going to explain a statement. In the statement, A be a 3 by 3 real matrix. Here one condition is given, then find out det A whole square. Okay, det of 2 adjoint of 2 adjoint of 2A is equal to 2 to the power 41. Here we have one formula, adjoint of Ka is equal to K to the power n minus 1 into adjoint of A. Here K relation, what number is there? Here 2 there. Now we should apply same formula, 2 adjoint of okay, now according to formula, right, K to the power n minus 1, here n value how much value? 3. Why? Because from statement A is 3 by 3 square matrix is given, n value 3, adjoint of, now applying same formula, K to the power n minus, K value here 2 to the power n minus 1, 3 minus 1 into adjoint of A is equal to 2 to the power 41. So det of 2 adjoint of here how much this is? 4 times of adjoint of A. So 2 adjoint of, again now we should apply same formula, here K value here 4, adjoint of A, let us take A matrix. According to same formula, right, 2 into, what is the formula? K to the power n minus 1. Here 4 to the power n minus 1, 4 to the power 3 minus 1 into adjoint of, inside matrix also adjoint of A there. Adjoint of A is equal to the power 41. Okay, here 4 square, 16 to the 32, this value. According to adjoint of 32 times of adjoint A is equal to the power 41. Here K value 32, adjoint of A, let us take A matrix. According to same formula, right, what we get here? Det of 2 adjoint of what is there here? 32 times of adjoint of A is equal to power 41. This is the previous step. Okay, now applying same formula, K value here 32. 2 adjoint of, what is the formula here? K to the power n. K to the power n is nothing but 32 to K to the power n minus 1. 32 to the power n minus 1, 3 minus 1 into adjoint of A is equal to power 41. So adjoint of A, let us take A matrix. Okay, same formula, that adjoint of K. Okay, we have adjoint of K is K to the power n minus 1 into adjoint of A. Here K value 32. Matrix A relation, right, adjoint of A. Okay, now we should apply this formula. K to the power n minus 1. 32 to the power n minus 1, 3 minus 1 into adjoint, this right, adjoint. Inside matrix is A matrix is adjoint of A. 32 whole square. 2 into, this is 32. 32 is nothing but 2 to the power 5. 2 to the power 5. 2 to the power 5 whole square, 2 to the power 10 into adjoint of A is equal to power 41. This is 2 power 11. Okay, according to, right, det of Ka is equal to K to the power n into det A. Here n value how much value? 3, order of the matrix. Here K value 2 power 11. This is 2 power 11. So 2 to the power 11. What is the formula? K to the power n. 2 to the power 11 whole cube. N value 3 here. This total matrix is A. Det of adjoint of adjoint of adjoint of A is equal to 2 power 41. Here this is 2 power 33 into, here three adjoints are there. We have one formula, that A power n minus 1 whole square, whole cube. N minus 1 whole cube is equal to 2 power 41. For 2 power 33, sending right side, it is divided. That A. N value, how much value? 3. 3 minus 1 whole cube. 3 minus 1, 2. 2 cube is 8. Is equal to 2 power 41 by 2 power 33. 1 2 power 33 get cancelled. Here 2 power 8. So therefore, that of A we get plus or minus 2. If base is equal, if powers equal, then base is also equal. That A is equal plus or minus 2. So what is required here? Required is that A square is required. What is required here? That of A square. So that A square is nothing but that A whole square. That A value we have got plus or minus 2. Plus or minus 2 whole square is equal to 4 answer. Okay, now explain next statement. In the statement, matrix A given 3 by 3. Then find out minimum value of delta of A by B. First, we have to find delta of A. Delta of A is equal delta of 2B1, B square plus 1, B, 1, B2. The plus minus plus. After simplification, we get B square plus 3. So that A value we have got B square plus 3. So what is required here? Required is minimum value of delta of A by B. First find out delta of A by B. Delta of A, B square plus 3 by B. Now write individual division, B square by B plus 3 by B. 1 B here get cancelled. B plus 3 by B. B plus 3 by B. Okay, we have minimum value of delta of A by B required. Okay, we have one formula. Arithmetic mean should be greater than or equal to geometric mean. Okay, arithmetic mean, right? Let us take two numbers. What is the formula? Formula is A plus B by 2 should be greater than or equal to root AB. Here, let us take A is one value, B other value is 3 by B. According to formula, right? B plus 3 by B should by divided by 2 should be greater than or equal to root under AB. AB means B into 3 by B. Here 1 B cancelled. Let us do cross product. B plus 3 by B should be greater than or equal to 2 root 3. What is the minimum value here? So minimum value of mod A by B is 2 root 3. This is statement B plus 3 by B is nothing but B plus 3 by B is nothing but delta of A by B. This minimum value is 2 root 3. Okay, now I am going to explain next problem. In the statement, delta of 3 by 3 matrix is equal to A plus Bx into x minus A whole square given. Then find the values of AB. So in the statement, x minus 4, in first row having x minus 4, 2x, 2x. In second row, 2x, x minus 4, 2x. In third row having 2x, 2x, x minus 4. Let us observe this depth. What is the one formation here there? Now, we should add all rows. What we get here? Here x, 2x, 2x total is 5x. Here also same, 2x, x, 2x, 5x. Here 2x, 2x, x. One combination will be there. That combination is 5x. 5x minus 4. If, okay, or we should add all columns. This is C1, C2, C3. That is also same combination. So C1 replaced by C1 plus C2 plus C3. Okay, here also C1 place here x minus 4, 2x, 2x. Sum of all columns is 5x minus 4. Here also same combination. Now we should applying column operations or row operations. Okay, now I will take column operations here. So C1 replaced by C1 plus C2 plus C3. What we get here? All columns are added. 5x minus 4. Here 5x minus 4. Here 5x minus 4. So remaining elements write as it is 2x, 2x, x minus 4, 2x, 2x, x minus 4. Okay, here I take 5x minus 4 in first column. I take common 5x minus 4 in first column. What we get here? 5x minus 4 into 1, 1, 1, 2x, x minus 4, 2x. Here 2x, 2x, x minus 4. Okay, now let us do simplify. Here, first column having all ones. Here, 2 ones make into zeros. Okay, here R2 replaced by R2 minus R1 by using first row, second row, third row make into zeros. First elements. R2 replaced by R2 minus R1. R3 replaced by R3 minus R1. So by using these two operations, what we get here? 5x minus 4 into first row write as it is 1, 2x, 2x. Here R2 minus R1, 0. Here R2 minus R1, x minus 4 minus 2x. Minus x minus 4, next value 0, 2x minus 2x. Here 1 minus 1, 0, 2x minus 2x. Here C R3 minus R1, 2x minus 2x, 0. X minus 4 minus 2x, it will be minus x minus 4. In this det, I take minus x minus 4 common in second row, minus x minus 4 common in third row. What we get here? 5x minus 4 into minus x minus 4 into minus x minus 4. Det 1, 2x, 2x, 0, 1, 0, 0, 0, 1. Here minus x, I take here minus common, minus into minus, it will be plus. So 5x minus 4 into x plus 4 whole square. Here this det value, how much value? Plus or minus plus, this det value 1. On comparing given x equation a plus bx into x minus a whole square. What is given here? A plus bx into x minus a whole square. What is the a value here? A is equal to minus a, x minus a whole square. X minus a whole square, here x plus 4 whole square. X a is equal to, we get minus 4. And b is equal to, here also a value minus 4. B value bx, here b value 5x. Bx value, here 5x is there, here x, b is equal, we get 5. Coefficient of x here 5, here b. What is the b value here? 5. So answers are a value minus 4, b value 5. Okay, next I am going to explain. Next question. In the statement matrix A, 2 by 2 given, 2 by 2 matrix is given. This matrix be written as P plus Q. A is equal to P plus Q. What is P here? Where P is symmetric matrix, Q is Q symmetric matrix. From statement, that Q value also given. What is that Q value? That of Q is equal to 9 given. Then find out that of P. Modulus of the sum of all possible values of delta of P, this is required. First, we have to find here A value. Okay, now what is the P here? P is a symmetric matrix. We have formula 1 by 2 times of A plus A dash. 1 by 2 times of from statement A matrix is there given 2, 3, A 0 plus transpose of A 2A 3, 0. What we get here? 1 by 2 times of 2 plus 2 4, 3 plus A 3 plus A 0. Here 1 by 2 multiply to all, what we get here? 2, 3 plus A by 2, 3 plus A by 2, 0. This is P matrix. Okay, now Q matrix is 1 by 2 times of A minus A dash. Q symmetric matrix formula this is 1 by 2 times of subtraction 2, 3, A 0 minus 2, 2A 3, 0. What we get here? 1 by 2 times of do subtraction here 0, 3 minus A minus 3, 0. It will becomes 1 by 2 multiply to all. What we get here? 0, 3 minus A by 2, A minus 3 by 2, 0. From statement delta of Q is equal to 9 given. So delta of Q value we have got 0, 3 minus A by 2, A minus 3 by 2, 0. What we get here? Delta formula AD minus BC. 0 minus of 3 minus A by 2 into A minus 3 by 2 is equal to 9. Here minus multiply with 3 minus A. What we get here? A minus 3. Here also A minus 3 there. A minus 3 whole square is equal to denominator 2, 2 j 4, 4, 9 j 36. Okay, let us take case 1. A minus 3 whole square is equal to 36. A minus 3 is equal plus or minus 6. Plus or minus 6, we should take A is equal to plus 6. A is equal to how much value? A minus 3 is equal to plus 6. A we get 9. A minus 3 is equal to minus 6. A we get minus 3. Okay, right here. Case 1, P is equal how much value here? From equation 1. Okay, P value. Here A is equal to 9. Substitute in P matrix. A is equal to 9. What we get here? 2. First write 3 plus A by 2. 3 plus A by 2, 0. Here P A plus 9 substitute. What we get? 2. 3 plus 9 by 2, 6, 6, 0. But that P value, how much value here? AD minus BC minus 36. Next case 2, find out P value. If A is equal to second value, how much value we have got it? Minus 3. A is equal to minus 3, then find out P value. P value, how much value? 2. Here A plus and minus 3 substitute. 2, 0, 0, 0. So that P value, how much value here? 0. So what is required here? Modulus of sum of all possible values of det P. So one first case det P value minus 36. So required is modulus of all possible values of det P. Possible values of det P. So E minus 36 modulus is how much value? Plus 36. So here, 1 minute. Here, modulus of the sum of all possible values of det P. Here we have got minus 36 plus 0 modulus. How much value here? Minus 36 plus 0 modulus is plus 36. The answer is 36. Thank you for watching. Remaining questions I will explain on next class.